Okay, a lot of questions over the distinction between network and work done by non-conservative force. Great question. You do need to know the distinction between those two. Okay, network, we learned that prior to talking about conservative or non-conservative forces. We had no comprehension of the distinction. Okay, this is the work done by all forces, conservative or non-conservative. It doesn't matter. It's all of them. Okay. Is equal to change in kinetic energy. The work done by non-conservative forces is just the work done by conservative forces. Okay, and that's equal to change in mechanical energy. This includes the work done by gravity. This does not. Okay, good with that? Give that one a shot.
It doesn't take the same as a height and a shoulder. No, but it's the same as height. Did you fill out the same?
Yes, we have.
Why is that the same?
Because they are.
Okay, what's it like when it shows the marble falling down the track? Wasn't it like more like part of the video?
When you did all the marbles, they all ended with the same speed. It just took longer for certain ones to get there.
Okay, that's
I'm
not
not exactly sure because there's no forces on why. I just remember that from.
Okay, my bar draft.
Yeah.
So I don't know. Right, because no work is being.
Okay, quick answer is C. This is just like the marble track. The colored marble tracks, yes?
Wait, because.
Okay. Mechanical energy is conserved. Here they have the same potential energy. We're going to make this ground zero. They have the same amount of kinetic energy at the end here. We're not saying which one wins the race. We're just saying once they reach this point, which one's going faster. They're identical. This one will probably win the race because it speeds up sooner. Good?
Yeah.
Okay. All right. Next question.
It's like 4. He's so like 4.
So here's your initial. Here's your final. Have a conversation. Why do you think so?
Something. What else is shooting it out of the gun? I was thinking 45 for some reason, but I don't. I'm saying like 45 and. There's because I said positive. Yeah, I think positive.
Correct answer is A. Okay, which way is the gun applying a force on the ball? Up. Which way is it moving? Up. Positive work. Okay, good with that? Positive work. So, same scenario. What is true? What is known about the mechanical energy? Think it in your brain. Think it in your brain. Don't influence or be influenced. Don't influence or be influenced. Don't influence or be influenced.
Wesley, you started it.
Don't influence or be influenced. Hot bean. Wait for it. Eat it. Now tell your neighbor what you think and why you think it.
Oh, I wait, we
The initial But increasing the potential in kinetic would increase the mechanical energy. Yes, you are. You're definitely increasing kinetic. At the initial, there's no.
Correct answer.
Everything can be put into
Correct answer.
these two?
But the potential's being gained to more supply.
Correct answer is A. Okay. The easy way. Here's the easiest way. The work done by a non-conservative force was positive. That was the previous question. So your change in mechanical energy is also positive, meaning it increases. Okay. Correct, not as direct way, but still correct, was the fact that it started at rest and now is moving. So you increase kinetic energy. You started at ground zero and now you are above that. You have an increase in potential energy as well. So increased mechanical energy. Good? Okay. I'll give you 30 seconds. We're going to draw several of these. So it's going to be one big story. So my recommendation would be several pennies. Make that ground zero. Start at rest at ground zero. You have no money in your bank initially. Okay. So it's positive work done. We established that already. I'm going to give myself 6 pennies. You can give yourself 4 pennies. You can give yourself 10 pennies. It doesn't matter. Okay. Now, at the end, the final, you have sorry. Retracting this. Relationship number 1. Your kinetic plus your potential gives you your total mechanical. Your checking plus your savings gives you your total balance. Okay, that's the relationship number 1. The relationship needs to be consistent. Relationship number 2. What you started with in the bank plus whatever you did in the process has to equal what you end up in the bank. Your total mechanical energy plus the work done, or your change in mechanical energy, is equal to your final amount of mechanical energy. So this plus this gives you need 6. Okay? Relationship number 2. Relationship number 3, we work backwards and we say, okay, that 6 pennies is distributed between your kinetic and your potential, your checking and your savings. It has both because it's above ground zero and it's moving. How you distribute these doesn't really matter. It could be 3 and 3, it could be 2 and 4, it could be 1 and 5. Okay, I'm gonna say 1 and 5 because it's just a little bit. Above ground zero, so the rest of it's in your kinetic. Okay, good with that? Okay, then we're gonna go from here to here. So I'm gonna make my initial here, final up to the top. Air resistance is present. Tell your neighbor what you think. Tell them why. Correct answer is? Correct answer is B, negative. Which way is the ball moving? Upward. Which way is force or air resistance acting? Downward is acting in the opposite direction motion, therefore doing negative work. And the consequence of that is we're going to decrease mechanical energy because we had a non-distributive force doing negative work. Seeing the connections there? Okay. So now for this is going to be unique in that I'm going to tell a whole story here for this whole process. Typically what I would do, what I would advise you to do, and on the test I want you to do this, and on the quiz, and on the lab, is take this just standalone by itself and make that your initial, this your final. You'd make the lowest point you care about ground zero. That's what you would do. For the sake of the story, I'm going to do something different. Okay? I'm going to keep this at ground zero. Okay? So what I'm going to do is going to take my final scenario here and I'm going to copy paste that just so we have a big story. Okay? So I had okay, so that's right here, moving fast. Considering this ground zero, that's why I'm giving it a penny there. So this plus this gives me that. You make up the rest. Okay, negative work is done by air resistance. I'm going to take 2 pennies away.
Is this the
Yep.
cans and stuff?
That's all I got.
Okay. Thank you.
Alright, so it's taking 2 pennies away. So I had 6. Take away 2. Now I have 4. Does that make sense? And so this plus this gives me that. It's relationship 2. Relationship number 3. This plus this gives me that. So like this is distributed amongst your checking and savings, but at the highest point, you are stopped. No kinetic energy. So all your mechanical energy, all your money is in potential energy. Good? Okay. Coming back down. Catch the ball. Like, we're going to catch it. It's right before it hits your hand. So this is your initial. This is your final.
So is there kinetic energy that's being like taken out? Is that being put into the potential energy on the left side? Like when
Some of it. Yep.
some of it?
Yep. Some of it's just being taken away. Tell your neighbor, tell them why.
Go ahead and stay direction.
The ball going
I feel like that one playing that was off.
Oh, yeah.
I know. I agree. This is what happens.
But it's negative because the direction. Wait. So no, it would be B. It would not be C. It would be B. This is going up. This is going down.
10th period of that. I always have to struggle with that.
No.
I just so.
Hey, what do you say?
B.
Yeah. Okay, we're gonna learn some something. We're gonna learn you something. Not grammar, but we're gonna learn you something. Okay. Which way is the ball moving? Downward. Which way is air resistance acting? Upward. In the opposite direction of motion. Okay? The sign of work is not determined solely by the direction of the force, but the direction of force relative to, compared to, which way it's moving. Negative work is being done by air resistance because it's acting in the opposite direction of motion. Everybody locking into that one. Rocco.
So will air resistance almost always be negative?
Air resistance will always be negative. In this class, air resistance will always be negative. Like a sailboat.
I could do that now.
Okay?
Sailboat, the sail.
All right, so for the sake of the story, I'm going to take this. My final was, now it becomes my initial. Okay, so I'm going to take this over here. So I had 4, yes? Okay. I'm going to take away 2. And so I'm left with 2. I'm at ground 0. So all my money that I have left is in kinetic. Follow up, or last question. Correct answer is there was no air resistance, C would be correct. But because there is air resistance, A is correct. A had, at the beginning, we had 5 pennies in kinetic energy. At the end, we only have 2 pennies in kinetic energy because air resistance took mechanical energy away. Okay?